In this video, we're going to find a polynomial given its zeros. So we're being asked to find a fifth degree polynomial that has a 0 of 1. That 0 has a multiplicity of 3. The only other 0 of the polynomial is negative 2. And the leading coefficient has to be a 2. So we're using a couple of knowledge of different things that we have going on in this particular problem. Lots of things going on in a pretty straightforward looking problem. So the first thing is that we know that 1 is a 0. So if 1 is a 0, we know that the factor theorem says that x minus 1 is a factor. So I know in particular that x minus 1 has to be a factor, but we're also told that that 0 has a multiplicity of 3. So even more so, x minus 1 to the third must be a factor because the multiplicity is 3. We're told that x minus 2 is also a 0. However, it didn't say anything about multiplicities. The only thing we know is that it's the only other 0. Now, we've already taken care of a degree 3 here with the fact that x minus 1 to the third is a factor of the polynomial, or the other way around is that we know that 1 has a multiplicity of 3. We've taken up a degree 3 piece, but we know that we need to get to a fifth degree polynomial. In order to be able to do that, I've got to use x plus 2 squared. The multiplicity of negative 2 actually has to be 2, not 1. So I'll use x plus 2 squared as the factor of that polynomial. So, finally, since we now know that we've got kind of the meat, if you will, we know that the x minus 1 cubed times x plus 2 squared has to be the basic bones of the polynomial. We just need to know what the leading coefficient is, what number to stick out in front. We're told the leading coefficient is a 2, so finally the polynomial has to be f of x equals 2 times x minus 1 cubed times x plus 2 squared. And if you go through all of the effort to multiply it all out, you'll get 2x to the fifth plus 2x to the fourth minus 10x cubed minus 2x squared plus 16x minus 8.